Hello, adventurers, and welcome to Floor 12, the Labyrinth. 11 halls you filled and locked each beast in its place. This hall holds no beasts at all, only the dark between the doors. And one question left: can you reach the bottom and by the shortest road? The stair out of the Hollow Whispers is the last one. You feel it before you see it. The air stops being a room and starts being a between. A draft moving through more doorways than you can count. Corridor calling to corridor in the dark. There is no wall of niches here. No self, no chart. There are only doors, and the doors open onto other doors. And somewhere past all of them is the bottom of the hold. I realize now I've been saying niches, but I should be saying niches probably for this. Yikes. Anyways, resume scene. McCown did not follow you down. Keepers of order do not go where there is none left to keep. But you are not alone. A low string sounds in the dark. An open note left to ring. And a voice you have heard at the top of every floor. Never singing, always saving the verse. Finally begins. 11 halls, says the nameless bard, walking just behind you the way he always has. And in every one you stored the beasts, a bag of them, a chain, a stack, a queue, a tree, a sorted shelf, a scattered whisper. You learned to keep a thing so you could find it again. He sets a hand on the nearest door frame. This hall keeps nothing. Look, there's no lich here. No goblin, no record at all. The labyrinth does not store the beasts, it stores the passages between them. Which room opens onto which, door to door? And so the question changes one last time. Not where is the lich? You answered that 11 times over. The question now is, can you get to the lich from here? And what is the shortest way down? I have followed you down every floor and sung none of it yet. I was saving the verse for here. The last room where the descent finally says what it was always about. You thought it was about storing. 11 halls of containers will make a soul think that. But watch what crossing this place asks of you. To find whether a path runs from this door to the liches, you do not build a ninth container. You reach back, and the queue you forged on the 7th floor becomes a way to search a maze level by level. And the stack you forged on the 6th becomes a way to plunge down one passage to its end before turning back. Two old friends, waiting in the dark exactly where McCown said they would be. The map itself you keep in a third old friend, the scattered whisper from last floor, a hash set. Remembering every room you've already stepped into, so a circle of corridors cannot walk you in rings forever. You will not build much here, you will connect, and crossing the connection is the whole lesson the storing was teaching you to reach. The descent was never about keeping the beasts, it was about finding the way through. So, each of these containers we have built, every one of them answered the same shape of question, or same type of question. Put this thing somewhere and allow me to get it later. We're now into the labyrinth, and this is the finale. And this is where we talk about graphs, which store connections. So that the official term would be vertices, but here this would be rooms in our dungeon, and they're joined by edges. But in here we would call them passages for our dungeon. And the work is not keeping but crossing. Given a web of rooms, can we get from one to another? And what's the shortest route to get to that room? This is the last floor of the dungeon. There is no new container for us to build. Instead, we're going to write a light adjacency list graph of the dungeon's rooms and then two traversals that reuse what we already built. Okay, so a few things to make sure we stick with here in this module. A graph will store the passages, not the rooms. Every prior data file described things: monster stats, item lists, a taxonomy of kinds. This floor, we actually have a text file, labyrinth.txt, has no stats at all, just which room opens into which. A graph is that, vertices connected by edges. Two rooms are classified as adjacent if a door joins them. A path is going to be what we call a sequence of doors from one room to another. And then the distance between two rooms is how many doors are on the shortest path between them. So we will build an adjacency list. So each room will keep a list of the rooms it has a door to. A dungeon map is going to be classified as sparse, a few doors per room, not a door to every other room. And the list only stores the doors that exist, which is exactly why it is the right shape. The alternative to this would be an adjacency matrix, which reserves a slot for every possible door, most of which are empty. Now, we're going to reuse two containers. The only difference is first in, first out versus last in, first out. So to walk the map, we need to visit the rooms in some order, and the order is set by which container holds the rooms you have discovered but not yet visited. So we're going to use our Q, which is FIFO. We will get breadth first search. We visit the start, then every room one door away, then every room two doors away, level by level, not revisiting. Using the stack, which is LIFO, we get a depth first search. We plunge down one passage to its end and then backtrack. So same map, same start, but a different order. And that difference is going to be nothing but the same stack versus queue question that we talked about before, but now steering a maze. Now, because breadth first search visits level by level, it will hand us the shortest path for free. Okay, so a breadth first search will reaches distance 1 rooms before distance 2 rooms before distance 3. Okay, now distance is going to be the short doors, the number of doors on the shortest path. Join those and the conclusion becomes automatic. The level at which breadth first search reaches a room is its shortest hop distance. In an unweighted graph, every door will cost us 1 step. The fewest number of doors has to be the shortest way down. And the BFS will find it with no extra machinery. Now, if we have a weighted graph where doors cost different amounts to traverse, we would need Dijkstra's algorithm instead. And that is where you would go with graphs next. So we can see here, the dungeon map is really a graph. You can kind of see the rooms that have different monsters in them, and then the edges between them, which are the passages. Okay, and then we have the same map on the right as an adjacency list, where each room keeps a list of the rooms it has a door to. Okay, the map, of course, is sparse. Most pairs of rooms are not connected, so the list stores only the handful of doors that exist. Okay, now, of course, we got to watch out for a sealed pit here, which would be this room over here that has nothing, no doors connected to it. Okay. And we also have a triangle here, and this entrance with the goblin and the skeleton is a cycle. Okay. We got to be careful of that. And then we can see here, same map, same start, 2 different orders. Right. BFS, right, we'll use our Q, and it fans out in rings, right? So it goes right across before going down. Okay. Meanwhile, with our depth first search, you notice will be the stack, and we're going to go down and plunge down the passage before backtracking. Okay, the container here is going to be what flips the order. The visited set is going to be the same for both, and it's what lets either one cross a map that has a cycle. Okay, and you can kind of see this stack here. We can on the top we can push or pop onto, and so you can see like here we have our lich, then our necrothal, then our skeleton, and then our entrance here. So you kind of see kind of how we do. We can push those things down there. Okay. Now, there is a fourth thing, of course. The most dangerous bug here is going to be where we have a cycle. Okay. Like that entrance, goblin skeleton entrance cycle where it feeds you back to where you start. So you're kind of stuck in a loop and you have this potential to get stuck there forever. The program in this case would not error out. It just doesn't return. Okay. So that's where we're going to use the unordered set from the standard library because it will remember, right? It has a memory of the room we have visited so we don't go into it a second time, okay? So that's going to be a huge thing here. Okay, so instead of us getting stuck here, we end up going, hey, wait a second. If I go this way, I'm going to get stuck. Therefore, I'm going to pop out, okay? All right, so here we are in the floor 12 build, and let's go ahead and build our executable here and kind of see where we are at so far. Okay, so we have a new command self-test crossing. And of course, we see we have a lot of fails happening here, right? So the big things here is, of course, this is our last floor, 11 halls, and in every one you stored the beasts. we dealt with a bag, a chain, a stack, a queue, a tree, a sorted shelf, a scattered whisper. This hall is going to not store beasts at all. We're going to store the passages, which door opens onto which. That's a graph. And the twist here that really closes the whole course out is that to cross it, you don't build a ninth container. We reach backwards. Right? So we're going to reach back to the queue and the stack. Now today, all 6 methods here that are being tested are stubbed. So we fail for all 6. Okay. So what we're going to need to do today is we need to work in the hero/graph header file for us today to get working here. Let's see, graph header, there it is. Okay. So the first thing we need to do is let's go ahead and scroll to our private member down here. So notice we have a trim, okay? So what's provided here, we have one member, and it's the whole adjacency list idea in a single declaration. This adjacency underscore here is an unordered map from a room name to a vector of room names. So adjacency of lich is the lich of rooms, is a list of rooms lich has a door to. Each key is a room, which is a vertex. Each value is that room's list of neighbors, i.e. its edges, okay? That is covered in the book as well, which is called, and you've probably heard of other places too, the adjacency list, and it's all handled there in one line. Notice it's an unordered map, last floor's hash map, the library version of the wall we built, which means copy and destructor are free. There are no raw pointers on this floor. The loader constructor reads the labyrinth.txt and calls our connect and addRoom to build the map once per line. Okay, so right now those are stubbed to do nothing. So the map loads empty, and that's where we get the self-test failure there. And if we scroll down as well, we can see where our graph constructors here should be towards the top. Yeah, so you notice here where we have the graph default, then we have the data path, and then we go through our txt file here and actually goes through and reads in and calls our connect and addition there. So it reads in that text file and gets our data constructed here, our graph constructed. Now, what do we need to do next? Well, we need to go to the addRoom stub, which starts right here. And so what we need. So you notice here it takes in a const string reference to a room. And to do this, we need to say adjacency room. So this creates an empty adjacency list for a new room. This is a no operation if present. Okay. That's what we have to do right there. So a vertex in an adjacency list is just a key with a list of neighbors. And a brand new room starts with no neighbors, an empty list. So addRoom just touches adjacency at that key, right? Adjacency of room as a statement. On an unordered map, that creates the entry with an empty vector if it's missing. And if the room is already there, it returns the existing list and leaves it untouched. That's the word to nail down here is idempotent, which means adding a room that's already on the map does nothing to its doors, okay? Notice this is the one place this for wants the square bracket insert. Here, the whole job is to make sure a key exists. Now, in a minute, we're going to be dealing with neighbors where the bracket insert is the bug, and we're going to use find instead, okay? Now, let's go ahead and go down to our connect stub, which should be right down here. Okay. And what we need to do for connect, notice it takes, we have a string A and a string B. So we're going to say addRoom A, addRoom B. We'll say adjacency A dot pushback B. All right, so we'll say A to B right there. And then we'll say adjacency B pushback A, B to A. Okay. So notice this is undirected. i.e. both directions. Okay. So what are we saying here? Well, this is really the most important line of this video. So I'm going to say the word twice here. Undirected. A dungeon door is a two-way system here. You walk through it, but you can also walk backwards through it. So connecting A and B is not just one push, it's two. A goes on to B's neighbor list and B goes on to A. Both directions because the edge is symmetric. So first we make sure both rooms exist by adding both of them. So connecting a new pair just works. Then we push each onto each other's lists. The single most common bug on this whole floor is riding only one of those two pushes. Adjacency of A push back B and then stopping. The map compiles and it even half works. You can get from A to B, but mysteriously not from B to A, a path that exists going one way and vanishes going backwards. And phase 2 of our self-test will check exactly this. After connect, B is in A's list and A is in B's. Both pushes every time. Now, let's go ahead and do our neighbors stub as well. So for this one, we're going to say auto it equals adjacency find room. I'll then say if it equals adjacency end, adjacency dot end. Okay, we'll return empty curly braces. Otherwise, we'll return the second of it. So, neighbors returns the list of rooms one door away, which is just the value sitting in adjacency for that key. But look at how we get it, because this is a callback to floor 10's monster, the phantom key. We use find, not square brackets. The question is why? Because this method is const, and because on an unordered map, square brackets on a missing key doesn't return nothing, it inserts a new empty entry. Ask neighbors about a room that isn't on the map with square brackets, and you'd silently grow the map with a phantom room. So we find the room. If it's not there, return an empty vector. Otherwise, we return its neighbor list. Phase 3 will check both halves. The right list for a real room, and that querying an absent room does not change room count. Find never operator bracket. Now let's go ahead and build what we've got here. Oh, got a bug here. Oh, that should be a period right there. Okay, let's build it now. Okay, and so now our first three phases are good. So phases 1, 2, and 3 are green. The map builds. addRoom adds a room idempotently. Connect adds an undirected edge both ways. Neighbors returns the list without a phantom insert. Phases 4, 5, and 6 still fail. Those are us traversing the map, which is going to be the second and third videos. So don't worry that they're red. Now, the payoff, let's actually see our map here. So see, Necrothal has a door to Skeleton Lich. Skeleton, of course, has one to Necrothal. Lich, of course, has one to Necrothal. So you can kind of see how this works here. So that's the whole adjacency list made visible on the screen. Each room, then the rooms it has a door to. Okay, so notice here, entrance opens into Goblin and Skeleton. Lich opens onto Wraith, Necrothal, and the stairs. And find Oubliette opens to no doors. So that's a sealed pit, a room reachable from nothing. We're going to use it in the second video to show a path that does not exist. Now, two things about the order. The rooms print in the hash map's bucket order, not alphabetical, because adjacency is an unordered map. On your machine, the room order may differ, but the doors within a room are in the order you connected them. So we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rooms and 10. Oh, it's right. I had it printed out below there. Yeah. 10 rooms, 10 passages. Okay. So that's the important thing to see there. Now, if we try to, we can try to ask one room for its doors directly. So we can say doors Lich. You can say from Lich, we can go to the Wraith, the Necrothal, or the stairs. So a one neighbor's call, the 3 rooms, 1 passage from the Lich's chamber. The map is built. Nothing has crossed it yet. We haven't walked from anywhere to anywhere. That's in the next video, and that's where our old buddy Q comes back to life. Okay? So hopefully this was helpful, and I can't wait to see you in the next video. Bye-bye now.